Hello to whoever happens to be watching. In this video, I want to talk about using the PDF method to find the transformations of random variables. So I would like to start by doing some prep work to make our work smoother. I'm going to define this transformation as another random variable. Let's call it u. And we want to write u as a function of h. As a function of y. So let's call this function h. So what does this function h do? I would say it takes in a value and then squares it. And the next thing I want to do is to figure out what values you can take. So from the question, we know that y can take values between 0 and 1. And u is equal to the square of y. And this would imply u can also only take values between 0 and 1. And to use the PDF method, to use the PDF formula, we need to check that this function h satisfies 3 conditions. The first condition it needs to satisfy is that it's 1-to-1 over the support of y. So it does not have to be 1-to-1 everywhere. It only needs to be 1-to-1 over the support of y. And let's see, the support of y is 0-to-1. And from 0-to-1, what does our function h looks like? So let me plot y on the horizontal axis and h of y on the vertical axis. So I would say from 0-to-1, it looks something like this. And yes, it is 1-to-1. Something that's not 1-to-1 would look like this, for example. So this condition is satisfied, and let's go on to the second condition. And the second condition is this h function needs to be differentiable. So it needs to have a derivative. And does it? So h of y is equal to y squared. This implies the derivative of y, h prime of y is equal to 2 times y. So yes, it does have a derivative, so it is differentiable. We have that as well. And let's move on to the very last condition. And that is h prime of y can be 0 only at finitely many points. And let's see if this is true or not. H prime of y is equal to 2 times y, which is 0 only when y is 0. So I would say yes, this condition is satisfied as well. So we can go ahead and use the PDF formula to find the transformation. And the PDF formula is f of u is equal to f of y evaluated at h inverse of u times the absolute value of the derivative of h inverse. So our only missing piece is finding the inverse of h. So this is how I would do it. So let's see, u is equal to h of y. This implies y is equal to h inverse of u. So to find the inverse of h, what we need to do is to express y as a function of u, and then whatever we get is the inverse. So we have u equals to the square of y. This implies y is equal to the square root of u. And this would be the inverse of u, the inverse of h. So the inverse of h is the square root function. And let's plug this in. F of u, so the PDF of u is equal to the PDF of y evaluated at h inverse of u, which is the square root of u, times the derivative of the inverse of h, and so the inverse of h would still be the square root of u. And let's take a look at the PDF of y again. So the PDF of y is 2 times 1 minus whatever is inside of the parentheses times the absolute value of 1/2 times 1 over the square root of u. And so we have already figured that, should be u, that you always take values between 0 and 1. So we can get rid of the absolute value. And in the end, we're going to get 1 over the square root of u minus 1. However, we have to pay very close attention to the fact that you can only take values between 0 and 1. So let's say for 0 less than u less than 1.